Hello, math students, and welcome to another edition of Mr. Hargrove's math class, where today we're going to be talking about solving two-step equations. For today, because we're going to be covering a lot of content, it's going to be very important that you have pencil and paper with you. So if you don't have that, please pause the video, grab pencil and paper, as I do want you to take notes and write down some very important steps to solving two-step equations. So let's go ahead and jump right in. The learning target for today reads as such: I will learn how to model and solve two-step equations. I will also learn how to plug my solution into the original equation to confirm that my solution is correct. The success criteria, and again, this allows us to know that we are on the correct path to achieving success and reaching the learning target, are the four following items. I can add and subtract integers to create a zero pair. I can multiply and divide integers to isolate the variable. I can determine the value of the variable, which is also the unknown piece. And I can plug my solution into the original equation to check for accuracy. Now, before we jump into this lesson, there is some prerequisite knowledge, which basically means that there are items that you need to be able to perform prior to achieving success in this lesson. So you want to make sure that you understand the rules with adding, subtracting, multiplying, and dividing rational numbers, especially the integers. You're going to see that we're dealing a lot with integers in this unit, so that's going to be very important. So let's start with this question. What is an equation? It's a very important question. Well, an equation says that two things are equal. The equal sign tells us that what is on the left is equal in value to what is on the right. So an equation is essentially a statement that says this is equal to that. And you're going to see the equal sign. Now, later on in this unit, we're going to talk about inequalities, and inequalities deal with items that are not necessarily equal in value to one another. But for today, we're just going to stick with equations. So you're only going to see that equal sign with the problems that you'll solve today. So here are some examples of equations. So if you look at the item here, 7 plus 2 is equal to 10 minus 1, you'll see that although the numbers are different, they equal the exact same thing, right? Because 7 plus 2 is 9, and 10 minus 1 is also 9, and 9 is equal to 9, so therefore that is an equation. And then you also have another form of an equation when you look here at this balance beam, or this, which is also can be described as a scale. What you see is the item on the left is equal in weight to the item on the right, which is why they are in the exact same position on the balance scale. So the scale balances. And that's another thing that equations tell us. They show balance. So you see a model of an equation. You see 1x on the left, and you also see 3 dots. So we would say that could represent x plus 3. And then on the other side, you see 7 dots. So we could say x plus 3 equals 7. And that's an equation, but it's modeled. It's in its model form. And then you have your standard algebraic equation, which a lot of the ones that you'll solve will look similar to this one, where you'll have a number, which we call a coefficient, next to a variable, plus or minus another number, and it's going to be equal to a number. But again, the important part is that equal sign, because it truly shows equality. And the variable, we're going to talk about what the variable is on the next slide, but you just have to keep in mind that the equations that you're going to solve are all going to have a variable. So what is the goal of solving an equation? Very important question. Well, the goal in solving an equation is to figure out the value of the unknown. And that's what the variable is. It's an unknown. And that's what we want to do. We want to figure out how much the unknown is worth. The variable is normally represented by a letter, and it could be any letter, A through Z. We normally in math represent that unknown with a letter. And we can figure out the value of the variable by following steps to get the variable by itself on one side of the equation and a number on the other side of the equation. And this is going to tell us the value of the unknown. So a lot of words, but you'll see this in action here shortly. So what are the two steps to solving equations? Well, there are two basic steps, and we're going to highlight and focus on those two steps today. And this is, again, what's going to ensure success throughout this entire unit. No matter what the problem is, you're going to follow these steps. You're either going to add or subtract to form a zero pair, and you're going to zero pair the number that is not connected to a letter. The number that is not connected to a variable, that's what you want to zero pair. Because remember, the goal is to get the variable by itself. So we want to make any number that is not connected to the variable a zero, and that's what zero pairing does. Next step is we want to multiply or divide to determine the value of the unknown. And again, we're going to see this in practice here in the problems that we're going to look at. So it says model and solve two-step equations with algebra tiles. That's what we're going to do right here. So we're going to model the equation 4x minus 2 equals 10. Okay. Now, it's very important to keep in mind that minus 2 and negative 2 operate the exact same way. So they mean the same thing. And that's very important for you to understand and make that connection when you're solving equations. Minus 2, negative 2, they mean the same thing, operate the same way. So this is the equation 4x minus 2 equals 10 modeled. You will notice that there are 4 x tiles, and then there are 2 negative tiles. And again, that's because negative 2 minus 2, they mean the same thing. So you have 4 x's, 2 negatives on the left, and then you just have 10 positives on the right. So that is 4x minus 2 equals 10. Now we want to solve for x. And when we solve for x, what we really want to know is how much are one of those x tiles worth. So when we solve for that unknown, that is really what we're figuring out. How much is one x tile worth? Well, to figure that out, I need to add 2 positive 1 tiles to each side of the equation to form a zero pair on the left. Because remember, we want to get rid of whatever number does not have a variable. Okay, so we see that the x's are represented, but I want to get rid of those 2 negatives. But it's very important, again, to note that whatever you do on one side of the equation, you have to do on the other side. So I'm going to add 2 positives because I want to make those 2 negatives go away. 2 positives will make them go to 0, but I also have to add 2 positives to the right side because remember, whatever you do on one side of the equation, you must do to the other. Now, I'm going to then remove both zero pairs from the left so that the variable is by itself. So watch this. I had 10 positives on the right, but now I have 12. And I have 2 zero pairs, so I can cross them out. And what that leaves me with is 4 x's on the left and then 12 positives on the right. So now that I've zero paired, I can divide the remaining tiles into 4 groups. Why 4 groups? Because there's 4 x's. And what I want to do is figure out how much 1 x is worth. And if you see what I've done here, when we group them, you'll see that each x tile can fit 3 of those positive tiles inside. So that means that the value of x is 3. So we've just solved this equation. So now let's move to solving it algebraically. Now this is the same equation, but now we're just going to solve it algebraically, and we're going to perform those same steps with just with just a couple of minor tweaks. Anytime you solve an equation, again, it's very important that you keep in mind what the goal is. So the goal in solving this two-step equation is to figure out the value of 1x. Now, this is the same equation that we just modeled and solved, but now I'm just going over how you solve it algebraically because this is the method that we want you to use. So the first thing that we want you to do to keep yourself from getting confused, put a box around the variable and the number next to it. And this serves as a reminder that you will not touch this item until after you zero pair the number that is not connected to a variable. So if you look at this equation, which one has a number and a variable that are connected? And you should see, well, it's the 4x. So I'm going to put a box. And when you solve these with your pencil and paper, I want you to write that equation out. And I want you to put a box around 4x. And that, again, that box lets you know I am not going to take care of that right now. But what I am going to do is take care of the item on the same side of the equal sign that does not have a box around it. And that is that -2. So I need to zero pair the -2 with +2. And remember, whatever you do on one side of the equation, you have to do on the other side. So I'm going to add 2 to both sides. And then I'm going to draw a line because now I have created a zero pair. -2 and +2 is 0. And I don't have to write it. I just know it. -2 + 2, 0. So now I'm going to bring down what's left. Now what's left? I'm left with 4x equals 12. Remember, the 10 becomes a 12 now because whatever you do on one side, you have to do to the other. I need to add 2 to both sides. Now, the next step, I need to divide both sides by 4. Why 4? Because I have 4 x's. And what I want to do, I want to figure out how much 1x is worth. So since I have 4 x's, I'm going to divide both sides by 4. And when you do that, that leaves you with this. 4 over 4 equals 1. So that's 1x, and then 12 divided by 4 equals 3. So 1x equals 3. Now this is actually the answer because remember the goal is to figure out how much 1x is worth. But in math, we never write 1x. It's just understood that when you have x by itself, it's just x. That's just understood. So this is the solution to this equation, x equals 3. But I could say 1x equals 3. But again, in math, when you have 1x, we just write x equals 3. So the next thing that we need to do, now that we know the value of x, we need to plug it into the original equation to make sure that our solution is correct. This is a very important step in math. I often have students say, hey, Mr. Hargrove, I solved this equation, but I'm not sure if my answer is correct. And I always say, prove it. That's how you confirm that your answer is correct. And here, I'm going to show you how to prove it. This is how. For the equation, 4x minus 2 equals 10, we just solved it on the last slide. We determined that the value of x is 3. So now we're just going to prove it. So I'm going to write the original equation, but now that I know the value of x, I can replace it. I know that x equals 3, so now I'm going to remove the x, and I'm just going to plug in 3. And what this is telling me, it's 4 times 3 minus 2 equals 10. And we'll see if that's true. If that statement is true, then I know my solution is right. Well, what is 4 times 3? 4 times 3 is 12. And then what's 12 minus 2? 12 minus 2 is 10. Does 10 equal 10? Yes, they are the exact same in value. So that is how I know that my answer is correct. So we just solved an equation and we proved it by plugging it back into the original equation. That is all you need to be able to do to be successful in this unit when it comes to equations. Okay, so let's move on to another two-step equation. And this time we've chosen a different variable. I told you the variable can be any letter A through Z. So this one says 6w plus 3 equals 12. Well, the goal in solving this equation is to figure out the value of 1w. I know that 6w plus 3 equals 12. How much is one of those w's worth? Well, to figure that out, we are going to put a box around the variable and the number next to it. And this serves as a reminder that we will not touch this item until after we zero pair. So we're going to put a box around 6w. And then the next thing that we're going to do is we're going to zero pair that 3. That's a positive 3. How do you get rid of positive 3? How do you get positive 3 to 0? Well, you got to add 3 negatives. 3 minus 3 is going to give me a 0. Remember, whatever you do on one side of the equation, you have to do to the other. I'm going to draw a line, and this is exactly what I want to see on your paper. You don't have to write all the words that are in boxes, but I want you to write the equation, box the equation, and then go through each step. I want you to write this out on your paper. This is going to leave me with 6w equals 9. So the next step is I need to divide both sides by 6. Why? Well, because there are 6 w's, and I need to figure out how much 1w is worth. So I'm going to divide both sides by 6. And what does that give me? That gives me 1w equals 1.5, because 9 divided by 6 is 1.5. You are going to solve for x, and you're going to get some rational numbers. Okay. So remember, in math, we don't write 1w. We're just going to write w equals 1.5, and that's my solution. That means the value of w is 1.5. Now, what do we do next? If, let's say, we solve this equation, but we're not 100% sure, we're not confident that our answer is correct. Well, the way you get confident is you prove it. Now that we know the value of w, we need to plug it into the original equation to make sure that our solution is correct. So the equation was 6w plus 3 equals 12, and we determined that the value of w is 3. So let's prove it. We're going to go 6w plus 3 equals 12, but what I'm going to do, I'm sorry, there was a mistake there. We determined that the value is actually 1.5. That's an error. Excuse the error. But we're going to keep going. We determined that the value of w is 1.5. So ignore that 3 that's up there. And what we're going to do is we're just going to plug it right into the equation. And what does that give me? Well, 6 times 1.5 equals 9. And then if I add 3 to that, that gives me 12. So that is all we're doing. 9 plus 3 equals 12. 12 equals 12. So that is how I know that my solution is correct. Again, I always want you to plug it in, and that's going to tell you whether you have done it correct or not. Because if you get a number like let's say 14 equals 12, well, that's not a true statement. So that means I've made a mistake somewhere. So this is always how you prove it. Always how you prove it. Now let's solve a two-step equation with a fraction. So you are going to see equations with fractions, but never fear. I'm going to walk you through everything you need to do. Same steps. Minor difference because of a fraction, but same exact steps. The goal in solving this two-step equation is to figure out the value of 1r. I know that 1/5 r plus 4 equals 8. I need to figure out how much 1r is worth. So I'm going to put a box around the number that has a variable and the variable that's connected to it. So that's going to be the 1/5 r. Now I need to zero pair. I need to get rid of that plus 4. How do you get rid of plus 4? Minus 4. You do the opposite. And then you bring down what is left. If you look on the other side of the equation, 8 minus 4 equals 4. So I'm now left with 1/5 r equals 4. Now, just pay attention here because what you want to focus on here is you want to make the fraction go away. So how do you make a fraction go away? Well, I'm going to multiply both sides by the denominator of the fraction to make the fraction go away. So here's what that looks like. What's the denominator of that fraction? Well, the denominator is 5. So what I'm going to do to both sides is I'm going to multiply both sides by 5. Now, since I have a fraction on the left, I'm going to put 5 as a fraction. And 5 as a fraction is just 5 over 1. 5 divided by 1 equals 5. So 5 over 1. And I'm going to multiply them. Now, look what happens. Remember, when you multiply fractions together, I'm going to do, and I'm looking to the left, 5 times 1, the numerator times the numerator, and then the denominator times the denominator. 5 times 1 is 5. 1 times 5 is 5. That gives me 5 over 5. 5 over 5r equals 20. Now, what does 5 divided by 5 equal? Well, 5 divided by 5 is 1. So I've solved this equation. 1r equals 20. Remember, in math, we don't write 1r. We just write r equals 20. So that is the solution to this equation. R equals 20. Now, we want to confirm that our answer is correct. So for the equation 1/5 r plus 4 equals 8, we determine that r equals 20. So now we're going to prove it. If r equals 20, then instead of r, I'm going to plug in 20. But I'm going to plug in 20 as 20 over 1 so that I can multiply it properly with that 1/5. And remember, when you multiply fractions, all we're going to do is simply numerator times numerator and denominator times denominator. And once we do that, that's going to give us exactly what we need. So when you multiply this out, what does it give us? Well, 20 times 1 is 20. 5 times 1 is 5. So that gives me 20 over 5 plus 4 equals 8. Well, what does 20 divided by 5 equal? 20 over 5 is the same thing as 20 divided by 5. And that's elementary math. That's 4. So 4 plus 4 is 8. 8 equals 8. So again, that's how we confirm that our solution is correct. All right, let's look at another equation, but this time it has a negative fraction. How do we solve that? The exact same way we did the other ones. The goal in solving this two-step equation is to figure out the value of 1m. How much is m worth? I know that negative 2/3 m minus 6 equals negative 14, but what is the value of m? Well, to figure that out, let's put a box around the coefficient and the variable. Okay, that's what the number next to the variable is called, the coefficient. We'll put a box around them, and then we're going to zero pair. We need to get rid of that minus 6. How do you get rid of minus 6? Well, you get rid of minus 6 by adding 6. But whatever you do on one side, you have to do to the other. Bring down what's left. What's left is negative 2/3 m equals negative 8. This is where you got to be sharp on your integer rules, because negative 14 plus 6 is negative 8. Okay? I told you got to be sharp on integer rules. So now we need to multiply both sides by the denominator of the fraction to make the fraction go away. So what is the denominator of that fraction? Well, it has a denominator of 3. So I'm going to do 3 over 1, because that is what 3 is equal to. And I'm going to do it the same thing on the other side of the equation. So if we go step by step, what's 3 times negative 2? 3 times negative 2 is 6. 1 times 3 is 3. So that's negative 6 over 3m equals negative 24. That's going to leave me with negative 2m equals negative 24. And then I need to divide both sides by negative 2 because I want to isolate the variable. And when I do, that is going to give me That is going to give me, what is negative 24 divided by negative 2? That's going to leave me with m equals 12. Again, you got to be sharp on your integer rules. Anytime you do a negative divided by a negative, that gives you a positive. So we had a lot going on in this problem, but we broke it down step by step. Now let's say, again, you solve it, but you're not 100% sure of your solution. That leaves us to the next step. Now that we know the value of m, we need to plug it into the original equation to make sure that our solution is correct. So just like we did on the previous problems, for the equation negative 2/3 m minus 6 equals negative 14, we determined that m equals negative 12. So I'm going to rewrite the equation, but I'm going to plug in 12 over 1. Why am I doing 12 over 1? Because I'm multiplying it by the fraction. So we want to multiply numerator by numerator, denominator by denominator. So I'm going to do negative 2 times 12 and 3 times 1. That's going to give me negative 24 over 3 minus 6 equals negative 14. And then your integer rules. What is negative 24 divided by 3? Well, it's negative 8. Negative 8 minus 6 is negative 14. Negative 14 does equal negative 14. So we have successfully solved this problem. So again, I appreciate your attention. We've gone through the steps of solving these equations, and now we're going to get started on some practice problems. Feel free to rewind, to pause, replay this video as needed. It's very helpful if you go through it a number of times to make sure that you understand every step, as you're going to use these same steps in the problems that we'll solve shortly. Again, thank you for your attention. We'll see you next time.